All right, guys, today we are solving trig equations. We are actually using identities with some of these, and we want to solve them. We're going to solve them over the interval from 0 to 2 pi, but we're going to have to do what we did yesterday where we find all solutions first, and then we can get our answers over 0 to 2 pi. So cosine of 2 theta, we're actually going to use the identity that cosine of 2 theta, you're going to go to use the double angle identity. So it's really 2 cosine squared, minus 1, okay? And then that's what you're substituting in for that. And then what you can do is you can subtract 3 cosine theta from both sides and add 2 to both sides. And so then here's the nice thing about this. Almost. The minus 1 and the plus 2, we're going to combine together. So we get 2 cosine squared theta minus 3 cosine theta plus 1 equals 0, right? Then here's the thing. It's actually just algebra from here on out, but it looks weird because we've got our cosine in it. What we're going to do is we are going to let cosine be x. So this is really 2x squared minus 3x plus 1 equals a 0. That is just factoring. No, I'm not going to walk you through it. I mean, you can do your whole, like the thing that you guys do where it's 2 and negative 3, and you then have your two numbers here, and you would split this middle group or middle term, and you would split it and regroup it, but I don't do it that way, especially because your numbers are so small. So we're kind of factoring in our head as we go. But guys, it's 2x squared. The only way to get 2x squared is to do 2x times x. And the only way to get 1 is to do 1 times 1. You just have to figure out what your signs are from there. But the fact that you have a negative 3x means you're going to have a minus 1 here and a minus 1 here. So you have 2x minus 1. And you can, by the way, guys, you can go back and double check it, distribute it and just double check it. 2x times x is x squared. Minus 2x minus 1x is minus 3x. Negative 1 times negative 1 is a positive 1. But anyway, we now have 2x minus 1 equals a 0 and x minus 1 equals a 0. So obviously x equals a 1/2 and x equals a 1. But you got to remember that it wasn't x, it was cosine. So you've actually just solved it without having to worry about the trig. So cosine of theta equals a 1/2 and cosine of theta equals 1. So you're going to your unit circle, and your theta equals 1/2 at pi over 3 and 5 pi over 3. And remember, we are, if we were writing all solutions, it would be plus 2 pi n plus 2 pi n. And remember, it's plus or minus depending on how you're rotating. Are you rotating up? Are you rotating down? Doesn't matter. That's just the direction of rotation. And then cosine of theta equals 1. That is only at 0 plus 2 pi n, okay? And so then what you're going to do is obviously for the interval, let's write it in yellow. For the interval, 0 is the smallest angle that we have. If I took this and I added 2 pi to it, well, I would already be at 2 pi then, and I would be, I'm not allowed to include 2 pi because it's just the parentheses. And so then my next angle is pi over 3. I can't add 2 pi to that because then I'd be over 2 again. And then the other angle is 5 pi over 3. So that's that. All right, we got sine of 2 theta equals radical 3 cosine theta. Again, we are going to use an identity, sine of 2 theta. That's another double angle identity. So you have 2 sine theta cosine theta. What I'm going to do is subtract radical 3 cosine theta from both sides. Okay, so that equals 0. Now, here, because you have sine and cosine, you can let 1 equal y and 1 equal x. So I'm going to let sine equal y. So 2y x minus radical 3x equals a 0. Okay, this is just a little algebraic trick. Now you can do, guys, honestly, if you look at like the PDF of the notes or any of the worksheets that I do, I usually just do it with trig. But I wanted to throw this little trick in there where you're substituting a y and an x in there. Really, ultimately, it doesn't matter. You're going to factor out a GCF. You got a cosine in both of them, or you have an x in both of them. So you factor that x out, and then you have x times the quantity 2y minus radical 3, that equals 0. So either x equals 0, or I'm going to just solve it, y equals radical 3 over 2. I would have added radical 3 and divided by 2. And again, because you were letting it letting x represent cosine, it's really where does cosine of theta equal 0, and where does the sine of theta equal radical 3 over 2. So that's what you're looking for. Now, cosine of theta is 0 at pi over 2 and 3 pi over 2. And again, all solutions would be plus 2 pi n. But again, because pi over 2 and 3 pi over 2 are on a straight line, we can write it as pi over 2 plus pi n. And then this one right here, sine of theta equals radical 3 over 2 at pi over 3 and 2 pi over 3. And again, all solutions would be 2 pi n for this. And then, of course, I'm just going to go through and actually just grab the initial or original angles on the interval from 0 to 2 pi. It's really just pi over 2, 3 pi over 2, pi over 3, and 2 pi over 3. You can't add anything to it. Like, it's not like yesterday where we had like 2 theta. Well, I mean, yes, technically we do have a 2 theta, but we're using a double angle identity right now. But it's not like, yesterday where we would have had like theta minus pi over 3 as our u. I keep pressing, like, I don't know if this is still recording or if it's, I'll have to sit down and watch it later. I don't know if it's flipping back and forth between the 2 pages or not. If it is, I'm sorry, guys. My new stylus is not quite as nice as I was expecting it to be. I shouldn't say that. I didn't, spring for the really expensive one. So yeah, it's about what I would have expected it to be. All right, so next, and we would have, oh crap, this pen, it's doing it again. This one is actually, if you look at the bottom of your identity sheet, at the very, very bottom, this is a sum and difference formula, right? There's my u, there's my v, right? And so it's going to be sine of theta. So sine, because it starts with sine, I'm going to add the 2 angles because there's a plus right there. So sine of theta plus theta over 2, there's my u, there's my v, right? Equals a 1. So then I'm going to have sine of 3 theta over 2 equals a 1. And this is, of course, one of the ones where we do like kind of like u substitution, where you say, hey, there's an angle out there that has a sine of 1. What is that angle? Well, it's pi over 2, and we'd write plus 2 pi n. But remember, we were using u to represent this, so you're going to take 3 pi over 2 and set that equal to pi over 2 plus 2 pi n. And you're just going to multiply everything by 2 and then divide everything by 3, so I'm just going to do that all at once. So you're going to get theta equals pi over 3 plus 4 pi over 3 n. So when you write your actual answers from 0 to 2 pi, you start with the smallest angle, so pi over 3. So then you're going to go to your calculator, 1/3, add 4 over 3, you get 5 over 3. If I tried to add another, 4/3, yeah. If I tried to add another 4/3, I would be at 9 over 3. 9 divided by 3 is 3, so those are my 2 answers right there. And I think this is our last one for today. So here's the deal. we are going to use a Pythagorean identity right here. So we've got cotangent to the fourth power equals 4 times, I'm writing the minus 17, 4 times 1 plus cotangent squared minus 7, okay? Then we're going to distribute everything out, and it's going to be straight up algebra again. It's actually going to be a quadratic. Okay, I'm going to subtract 4 cotangent squared theta. 4 minus 7 is a negative 3, so I would add 3 to both sides. Okay, so here's the thing. This is just a straight up quadratic. The only thing that's going to cause us a little bit of problem, which again, it's not a big problem, is this right here. It's to the fourth power and squared instead of squared into the first power. Not too huge a deal. Now, if you want to rewrite it in algebra, that's okay. Let's just let it be x to the fourth minus 4x squared plus 3. So when I do this, well, I know it's going to have to be x and an x, but it's going to be x squared because x squared times x squared is x to the fourth. And I know I need to get a 3. The only way to get a 3 is 3 times 1. And I know that needs to be a positive 3, and this needs to be a negative 4, so it's just minus 1 and minus 3. And so then I have this where I've got, okay, x squared equals a 1, so x is going to be positive and negative 1. And then x squared equals a 3, right? If I, set it equal to 0, then add. And so x is going to be positive and negative radical 3. The problem was this was cotangent. Okay, so from the first one, where cotangent theta equals positive negative 1. Now, you've got to remember, cotangent is x over y. And so you're going to get pi over 4 and 3 pi over 4. And guys, you can use your calculator. Remember, I don't like that. That looks terrible. You can use your calculator and just do inverse tangent. Good grief. It's like the smartboard when I erase. It erases one tiny little thing at a time. All right. So, and this is going to be plus, I should have a 2 pi. Yeah. I don't know why I don't have 2 pi. Oh, no, I know why I don't have 2 pi. Because it's positive and negative 1. So pi over 4 is where it's going to be positive. And add 1 pi will be, that's in the first quadrant, and then add 1 pi, it'll be in the third quadrant, it'll still be positive. Then here, 3 pi over 4 is in the second quadrant, that's where it's our negative 1, and then it'll be, add 1 pi, it'll be 7 pi over 4, that's where it's fourth quadrant. Okay, I was like slightly concerned. And then we're gonna have the same type of thing here where we've got cotangent of theta equals positive and negative radical 3. And again, use your calculator, inverse tangent. Nope, sorry. 1 over, so 1 divided by the tangent. Nope. Inverse tangent of 1 over, that's what we have to do. Sorry about that. I'm going to write it. Inverse tangent of 1 over radical 3, if you do it that way, because that'll help you out. Then you can just plug it into your calculator that way, and you'll get your first angle. And of course, because we want the positives and the negatives, pi over 6 plus pi over k gives me the positives. And then 5 pi over 6 plus pi over k, and I'm looking at my notes previously, so I don't have to memorize too much of it, and I wrote k. And again, pi over 6 is the original one. You add 180, you're in the third quadrant where it's positive again. 5 pi over 6 is where it's negative, and then you add 180 or 1 pi, and you get into the fourth quadrant where it's negative again. All right, so here's the deal. Oh, that's a lot of stuff. I think this one example took longer than any of the other ones. So we want to go from 0 to 2 pi, right? So I'm going to start with my pi over 4s. So pi over 4, right? And then 3 pi over 4. And then 5 pi over 4. And 7 pi over 4. So pi over 4, add pi, you get there. 3 pi over 4, add pi, you get there. Okay? Then, I'm going to make this a little bit smaller. I ran out of space, guys. I'm sorry. Oops. Okay. Then, your pi over 6, if you add pi to that, you're going to get 7 pi over 6. And if you add another pi, you're going to be too far. You're going to be past 2 again, so that's not going to work. So then you go back to the 5 pi over 6, which is the other angle that you found, and add pi to that, and you will get 11 pi over 6. Okay, and again, if you added pi again, you'd be too far. That was really long. I'm sorry. That one slide is like 6 minutes long. I'm so sorry, guys.